We're taking a close look at strings in computer programming. Let's dive right in. We often think of words as a sequence of characters. For example, the word Mona can be represented in a character array as M-O-N-A as array elements. Each character has its own place, its own index in the array. But when it comes to working with characters, there's a more convenient data type: strings. A string allows us to store a sequence of characters. While strings and character arrays are similar, strings typically contain ASCII characters ending with a null character and are of variable length. In programming, when we implement strings, we enclose characters in quotation marks. Take these examples. This is a string, apples, and the string 78429. Notice 78429 is treated as a sequence of characters, not as a number. You can't compare or perform numeric operations on it like you would with integers. Let's explore what a string actually is. Think of it as a necklace of characters strung together to form a line of text. In programming, strings represent text. They can be as short as a single character or as long as an entire book. Practical examples of strings in coding are everywhere. Usernames, passwords, product descriptions, search queries, all these use strings. Let's look at an example. In this example, str includes letters, numbers, and symbols, demonstrating the variable length of strings. Now, let's compare strings to arrays. Both can be accessed via indexing, but there are differences. In many languages, strings are immutable, while arrays are mutable. The size of a string is fixed upon creation, whereas arrays have a fixed allocation that may exceed the actual elements used. Strings are used for sequential text data, while arrays hold collections of any data type. Arrays can be homogeneous or heterogeneous, storing elements of the same or different types. They can also be multidimensional. Strings, however, are strictly for character data and offer various manipulation methods. Take this example. Here, mixed array contains an integer, a string, and an object, showcasing the versatility of arrays. Storage-wise, arrays can be fixed or variable length, defined at the time of coding or during runtime. In contrast, strings are of variable size, with memory allocated at runtime. Finally, let's talk about immutability. Strings in many languages are immutable. Once assigned, their value can't change in memory. Arrays, however, are mutable and can be modified after creation. For example, here, str was initially Jake and later changed to Jack, but both Jake and Jack are separate string values. To sum up, while both strings and arrays provide indexed access, they serve different purposes in programming. Strings are for text, arrays are for flexible collections. Understanding their differences helps us select the right data structure for our coding needs.